Okay, Assalamualaikum. I'm recording this session for those who are absent today. Hiba, if you need to come a little bit closer, you can. You can come in this space. Okay, that's fine. Do you want to log into my Zoom? It's tinyurl.com/Miss Yasmin. Okay, so we're doing 11.3 limiting reactions. If you don't have this header already written, write it down. But we already started some of this I believe on what's that, Friday? So I'm gonna go through real quick and then we're gonna jump into the new stuff, okay? The meat and potatoes of it. Okay, so the objective of today's lesson is to determine which reactants are limiting reactants and which are excess reactants. Students will be able to determine the mass in grams of the excess reactants. So that's the part that we didn't get into. We just got into identifying which one is limiting, which one is excess, right? Okay, so here are the definitions. You guys can, are you in? tinyurl.com/Miss Yasmeen, Yasmeen.
Need like a flat surface. She's just real tight.
This, like posted?
Huh?
Are they posted?
The slides are posted, yeah. Okay. So the definitions are here. You guys should have written that before, but just to quickly go over the definitions, a limiting reactant, a limiting reactant is something that is totally consumed up during the chemical equation. It limits the extent of the reaction. Okay, so it limits how much how many things can happen, okay? And it determines the amount of the product. Excess reactants is a reactant that remains, is excess, okay? So after the reaction is done, there is excess of this item, okay? So going over the quick example that I had told you guys on Friday, it was I'm making kunefa, and I need to make the sharbet, or the simple syrup to put on top of the kunefa, okay? I have a party. I'm going to make 3 or 4 kunefas, but I need to make the simple syrup. Now, the simple syrup, the recipe is 1 cup of water, 2 cups of sugar, and half a lemon. But I walk into my pantry and I notice that I only have 6 cups of sugar. What is the limiting reactant? What is the excess reactant?
Where did you post the slides?
You'll find that on chapter 11, which is like 2 weeks down. It says, right? It says like week of blah, 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 chapter 11.
Yeah.
That one has the slides in there. Okay, so what is the limiting reactant? What is going to limit how much?
Sugar.
The sugar. The sugar is the limiting reactant because I only have 6 cups of sugar. That's going to limit how many recipes I can make. I have an excess number of water, and I have a half. I didn't tell you guys how many lemons I have, but let's say I had like 6 lemons. Then I can make, with 6 lemons, I can make 12 recipes, right? But what's stopping me is the sugar. So that's my limiting. My excess reactant in this case is my water and my lemon. Okay, now this is a super simplified version. This is a super simplified example. But in chemistry, this is the logic, the base logic of what a limiting reactant is and what an excess reactant is. But obviously, we need to do a lot of math to figure that out, okay, in chemistry. But this is just so you guys can understand what this even means, okay? So one more visual before we jump into the new stuff is that here's an example of making ammonia. So NH3 is ammonia. Okay. NH3 is ammonia. Okay, so NH3 is ammonia. Okay, and what we have here is that you need, in order to make ammonia, you need 1 N, which is 1 nitrogen, and 3 H's, 3 hydrogens. The chemical equation to make ammonia, okay, is no, it's 3 molecules of nitrogen. Okay, so 3 molecules of nitrogen plus 3 molecules of hydrogen react to produce NH3. And we can balance this. We can balance this by putting where did I mess up? 3 molecules of nitrogen and 3 molecules of hydrogen react to form NH3. I think I messed up. I think I did a typo. It's 1 molecule of nitrogen. That's what's messing up. This says 3 molecules. Sorry, guys, this is a typo. That's one molecule. Okay. So that's 1. And so to balance the equation here, I would put a 2 here. So now I have 2 nitrogens on this side, 2 nitrogens on this side, 6 hydrogens on this side, 6 hydrogens on this side. With me so far? Okay, that's a balanced equation. Now, what does that actually look like in real life? And to answer the question is saying, what is the excess reactant and what is the limiting reactant? Okay, so to answer this question, let's look at this visual. Well, ammonia is 1 nitrogen, which is the big green circle, and it's 3 hydrogens, which are the small beige circles. So if I were to take one of the big green ones to make this, and 3 of the small beige ones, now in order to make this first ammonia, so I was able to make 1 ammonia molecule with what was given, correct? Now I can make a second ammonia molecule with what is given here and here. So now I have a second ammonia molecule. In this case, everything that was given was used up. So in this case, there was nothing excess and there was nothing limiting, okay? But in other examples, there may be 2 more hydrogen molecules here. If I had 2 more hydrogen molecules over here, then what is the excess reactant? The hydrogen, because what is there in excess? Hydrogen. And what is my limiting reactant?
Nitrogen.
Nitrogen, because we used up all of it. And it is limiting the amount of ammonia molecules I can create. Yes? Okay, good. So now let's jump into new territory here. Write this down. This is we're writing this down now. This is the concept. So we're calculating the amount of like production is happening when a reactant is limiting. So write this down. So how do we do that? How do we calculate how much is being produced?
Do you have a copy of the test?
Which one?
Yeah, like,
Oh,
it's not in there.
like a plain one?
Yeah, just in the blank one. Nope,
I don't.
not that. No, I'll just look at the essays.
She doesn't have all the student ones? They're in there, yeah.
No,
It's
that's
just the essays that are there?
the essay and the answer sheet.
Oh. All right, just to look at the essays and then math, make sure the math is looking good.
I don't know how many points each question is. I imagine
One each.
Even the writing, they're equivalent to multiple choice.
Oh. I don't know. Let me see it later. Bye. Okay.
So, yes, I know that.
Okay. Okay. So here are the steps for calculating the amount of product. Write this down. This is really important. So these are the steps. We're going to get used to it when we practice it. But like I said, everything in math, everything in chemistry builds up. We're going to be using a lot of the ratios that we were working on in the last couple of sections, and in the past chapter, we're using all of that stuff. So write these down. So step 1 is to find the moles of each reactant. Then you're comparing the mole ratios of the reactant to the mole ratios in the balanced equation. From then, you get to determine the limiting and the excess reactant. And then you're going to use the moles of the limiting reactant to determine the number of moles in the compound that is in your question. And usually the question is asking you to find mass. So that's where we're finally going. We're finally going to find the mass of the compound. Sometimes the question is also asking you how much excess. So that's that bottom sentence over here. Excess is found by subtracting the mass of element from the mass given. خلاص كسرها.
لا والله.
يا
آه.
طب يلا.
It's just me.
Hmm.
Do you think it's possible we can get like an extra credit project?
Hold no, I said that. We're going to have a quiz and a test. That's going to help you guys. Inshallah. If we do well. Done? That's that. All right.
We'll do last step. Last step. You guys,
Okay.
you guys are registered for.
What's going on YouTube? Okay, here is an example. Okay. I want you guys to write this example down. Important. Okay. So the example, let me magnify my screen so we have more space. Okay. The reaction between solid white phosphorus. Okay. So phosphorus or white phosphorus and means plus, right? Oxygen produces means the arrow, right? Yields solid tetraphosphorus decoxide, okay, which is this. This compound is often called diphosphorus pentoxide because its empirical formula is P2O5. So basically the empirical formula, if you guys Salah?
Huh?
Okay. The empirical formula, if you guys remember, is the simplified version of the molecular formula, yes? Okay. So if the molecular formula is P4O10, the empirical formula, simplified, divide by 2 gives you P2O5. Okay. So the question now is asking what? So let's first, we always start with what? Doing what? Balanced equation. Whenever working with anything, we always start with balanced equation, yes?
What's that? The tetraphosphorus? What is it? Is that like?
It's P4O10.
Oh,
Okay. So we're going to write the equation. So P4 and, so So we're going to start with our equation.
Plus O2.
Plus O2 oxygen gives us P4O10. Okay, now we balance.
You just put a 5 over there.
Okay, so I put a 5 here and we're balanced. So you always start with a balance. It always starts the same. We always start with a balanced equation. Okay, now I got the balanced equation. Now I'm going to jump into my question. What is my question asking? Determine the mass. Mass is what? What is the unit for mass? Grams. So I'm looking for number of grams, right? Of P4O10. So that's my question. My question is asking for the number of grams of P4O10 formed if 25 grams of P4 and 50 grams of oxygen are combined. Okay, so now I need to go to my steps. The first thing that I need to do is find which one is excess and which one is limiting. So in order to find which one is excess and which one is limiting, I'm going to my steps. My first step said that I need to find the moles of each reactant. Yes, that was step 1. Find the moles of each reactant. Okay. I'm doing step 1, Salah. With me?
Yeah.
Okay. Find the moles of each reactant. So these are the reactants. So I'm finding the moles of P4 and I'm finding the moles of O2. Yes? Okay. So they gave me 25 grams of P4. So I'm going to convert what is given. We always start with what is given. I'm given 25 grams of P4. And I need to find out how many moles. So what do I need to put on the denominator?
Grams.
Grams.
P4.
Grams of P4.
Mole.
And I need to put on top
Mole.
moles of P4. So there's always 1 in front of mole when we're comparing it to grams, right? Because it's grams per mole, right? Atomic mass of P4. So you guys-
Phosphorus.
So you guys, here,
Multiply that by 4.
I think I have the chemical final right
He
here.
has it, he has it.
Okay,
30.97.
30.97?
Yeah.
Okay, so 30.97 times 4 is 123.88. So 123.9.
You divide it.
So now I'm going to divide, and that's going to give me moles. The first step was find the moles of each reactant. Okay, so now I'm going to divide. So 25 divided by 123.9 is going to give me 0.202. Are we writing this down? 0.202 moles of P4. Okay, my first step said find the moles of each reactant. I still have 1 more to go. Okay, so what did they give me?
50 grams.
50 grams of oxygen. So I'm going to take 50 grams of oxygen and I'm going to cancel out grams of oxygen.
And then
Oxygen is 16, yeah.
So 32.
So 32 per 1 mole.
of O2.
This is going to cancel out this. 50 divided by 32 gives me 1.56.
Sarah Kasabi to the office for dismissal.
That's my first step. Did you guys write this down? We're with me so far? My first step is taking what is given in terms of gram and transferring it to moles, okay, for the reactants. The second step is now
Nalan to the office for dismissal.
I want to calculate the actual ratio of what is actually happening with these reactants. What is the actual ratio? Okay. The actual ratio of what is happening, knowing the actual weight. So a chemist is actually in the lab and he's like, this is my P4 and this is my oxygen. And he's actually using a certain amount of P4, 25 grams, and he's using a certain amount of oxygen, 50 grams. These are the actual numbers that he's weighing together, right? Okay, so I want to know what in this cup, in this beaker, when I mix these two together, right? What is the actual ratio between both of these elements. How do you find any ratio? Something over something. Okay, so to find the actual ratio of what's happening given the grams, given the actual grams, I'm going to divide these two numbers. Which one should I put on the numerator and which one should I put on the denominator?
Should this bigger one be on top?
You always put the bigger one on top. So the actual ratio
1.5.
Is 1.56 moles of O2 over 0.202 moles of P4. Now I'm going to put that in my calculator to give me nicer numbers. Okay, to give me whole numbers. So I'm going to divide. So 1.56 divided by 0.202, and that's going to give me 7. This is going to give me, I'm bringing it up here now, 7.72 moles of what's on top, oxygen, compared to 1 mole of P4. Okay, now I got the actual ratio of what happened in my beaker, that the chemist mixed these two items, right? And now I want to compare it to my chemical equation. What is the mole ratio between these two elements?
Wait, miss.
Yes.
How'd you get those new numbers? 7 point.
I divided. I did 1.56 divided by 0.2. And then I ended up getting 7.72. So now it's 7.72 over 1. Okay. Oh my God. The Monday morning. I mean, tomorrow, Tuesday morning.
Right.
Okay, tomorrow morning. Okay. Okay, so that's how I got this number, okay? Now I want to compare this ratio of what is actually happening in the lab to what my chemical equation said is most likely going to happen, theoretical.
Is it 5 to 1? Because O2 has 5 moles.
Beautiful. So what is the mole ratio from our chemical equation? Our mole ratio from our chemical equation is that 5 moles of O2 will compare with 1 mole of P4. That is what the balanced equation is saying. Comparing this actual ratio, comparing the actual ratio with the ratio from our chemical equation, which one of my elements is the is going to be my limiting reactant, and which one is my excess reactant? Phosphorus is limiting, and
Can you explain?
oxygen is excess. Why? Because what?
There's less of it.
How?
It's 0.202 moles of phosphorus and 1.5 moles of oxygen.
No, that's not the reason why. Because when you compare the ratio of what actually happened in the lab to the ratio of what was given in the chemical equation, in the lab, we had 7.72 moles of oxygen. And in the chemical equation, it's saying that we only needed 5 moles. So in the lab, we had extra moles of oxygen, which means that oxygen was your excess reactant. Because when you compare this ratio with this ratio, remember the green is in the lab because it's based on specific grams. So now we're getting specific, right? So in the lab, we had 7.72 moles per oxygen for every 1 mole of P4. So
Habiba to the office for dismissal.
So if we had 7.72 moles of oxygen in the lab, and our chemical equation says that we need 5 moles of oxygen. Comparing these two numbers, 7.74 moles is more than what we needed. Therefore, oxygen is in excess. Does that make sense? And if oxygen is in excess, that means P4 is limiting. Yes? Okay, so we have to write that down. So now we've determined that our limiting, go ahead, write this down. Did you guys write this nice? Our limiting reactant is P4. Hossein with me? Yes? Okay, and our excess reactant is what?
P4 no oxygen.
Our excess reactant is oxygen. Okay, I'm going to clear the screen. We're ready for me to clear the screen so we can move on? Because I'm not done with the problem yet. I didn't even answer the question. The question says, determine the mass of this compound that's formed. I'm not there yet. I just needed to identify which one was my limiting reactant first. So all of this was to determine which one's the limiting reactant. Okay. Now I determined what's my limiting reactant, which is P4. I'm going to clear my screen. Okay. So now I have to use the limiting reactant to determine how many moles there are in the compound. So I have to take my limiting reactant and determine how many moles of the compound that I want are in the reaction. So we do need to write our chemical equation again. So that's P4 plus 5O2 gives us
P4O10.
P4O10. Okay, so how do we go from moles to moles of any of these things, the reactants? How do I go from moles of any of the reactants to moles of the item that I'm looking for in the question? Because this is what I'm looking for in the question, but I have moles of these things. Which one did I figure out that I had moles for? Which ones did I do in my math? And okay. I did find moles of P4. I did find moles of P4, right? What was my moles of P4 originally? Okay, so I did find previously that I had 0.202 moles of P4. Can I use this to help me find how much mass I'm going to have of P4O10? Yes, because I can compare moles to moles first, right? This is going back to last section, what we did last section. I can compare moles of P4 to moles of P4O10, yes? Okay, so I know that I had 0.202 moles of P4.
So you put mole of P4 on the top.
So now I put 1 mole of P4 on the bottom, and I want to compare it to what?
P4O10.
P4 of 10. What in my equation? I have 1 mole of P4 to 1 mole of P4O10. So just so happens that this is going to be 1 on top here.
Can't you just convert it to grams by writing grams of P4O10?
No. Because remember, I did give you guys 3 ratios that you can use. Moles of something over moles of something else. Yes? Moles of something over grams of that same thing.
Oh.
Remember?
Yeah.
And grams of that same thing over moles of that same thing. Remember? Now that we're trying to change one element to another element, it has to be moles over moles. Remember that?
Yeah.
So everything that we learned before piles up, yeah? Okay, so my goal is to get the mass of the compound, but I need to start with the limiting reactant. I found out that my limiting reactant was P4. That's why I'm working with P4, because that is going to limit, my sugar is limiting how many recipes of simple syrup I can make for my kunefa. So I need to work with my sugar. I can't work with my water. There's extra of my water. I can only work with the thing that is going to limit how much reaction I can have, which is sugar. So in this case, what is limiting? We said P4 was limiting. So I have to start with the moles of P4 in order to answer my question. Yes? Okay, with me?
It's just
So
gonna
this
be
cancels out this. So now I have
0.2.
0.202 moles of P4O10. Did I answer my question? No, my question's asking for what? Mass of P4O10. Well, I got P4O10, but it's moles. In order to turn it into grams, you guys know how to do this. We should know how to do this. It was in the final. It was in our last section. 202 moles of P4O10.
Put it on the bottom and then you put P4 10 grams on the top.
Beautiful. And I put grams on top. And what do I need to do?
Find the atomic mass for that.
Atomic mass. Okay, so P you said is what?
3.97.
Okay, 30.97 times 4.
I'm going 21.
Okay, 123.88, right? Plus,
Actually, 16 times 10.
okay, so 160 plus, what did I say? 123?
123, yeah.
123 point what? Okay, so it's 283.9.
Multiply by that.
Yep, 283.9. And that's a multiplication situation. So 283.9 times 0.202 gives me 57.3 grams of P4O10. Now I answered my question. Yes?
Yeah.
No. We're not ready to go. We're not ready
All
to go.
this is one question.
All of this for one question.
Well, that's
So how many questions it quiz?
like one question.
Like literally two, maybe.
2?
Like maybe two on the
Means if you
quiz.
fail one, you get a 50.
Yeah, this is a tough one, yeah. Maybe I'll break it down into multiple parts. I don't know. We'll get there when we get there. Okay, but we're
What are we
still not
saying
done.
next-
There's a part B. There's a
Next
part
week,
B.
yeah, how to-
So any questions on this? Did you guys write this down?
Oh,
This has to be one question.
The second one is easy. This B is very easy. Okay.
okay.
But did we write this down?
Yes.
Yeah.
Okay. How much excess reactant remains after the reaction stops? What is the question asking? Make sense of it. How much excess is left over? What was our excess?
How much more?
What was our excess thing? Oxygen was our excess, yes? Okay. How much is asking you what? What's the unit that they're asking you?
Much of the excess.
Grams. How much excess? So what is the question? Grams of oxygen excess. That's what they're asking. They're asking how many grams of oxygen was left over. But what did they tell us? They told us, can you shut the door, please? They told us that we're using 50 grams of oxygen. Okay, let's bring our equation back into play. Okay, we used 50, we have 50 grams of oxygen that the chemist was playing with. How much is left over? So what we need to do is we need to take our limiting reactant again, because that's the one that is going to give us a true value. Remember, the sugar is going to tell us how much leftover water we have, how much leftover lemon juice we have. So we're always going back to the thing that was limiting our reaction. The thing that was limiting our reaction is going to help us find how much excess oxygen we have. The thing that was limiting our reaction was 0.202 what? Moles of P4. How do I go from 202 moles of P4 to oxygen? What do I need to do? What do I need to do? I'm trying to go from here to grams of oxygen. What do I need to do? Moles to moles, right? So now I need to put moles, with me, Salah? Moles of P4 over what? Moles of oxygen. Where do I get these numbers? Balance equation. 5, 1, okay, that's going to give me 1.01 moles of O2. Okay. Did I answer my question?
No.
No, because I want how many grams was left over. So I need to first get grams of oxygen, right? So I have to do 1.01 moles of O2 times moles of O2 on the bottom, yes. Grams of oxygen on top, yes. What's it's 16, right? 16 times 2 is 32. 32, yeah?
Yeah.
Okay. And that gives me 32.3 grams of oxygen. So the chemist used 50 or had 50 grams of oxygen to use. How much did we actually use in the experiment? 32. Answer my question now. How much excess reactant remains after the reaction stops? How much extra? 17.7. How much extra oxygen is left over? What do? 50 grams was given to the chemist to use, minus he used 32.3. So how much extra oxygen was left over? 17.7 grams of oxygen.
Right there, right when we got the answer to the already.
Subhanallah.
One full
Okay,
period on one.
so what you guys
One question.
is this next problem. Okay, on your slide. This next problem on your slide is your homework. Okay.